Alright, today we're going to rewrite and evaluate logarithms. So welcome back from spring break, and we're jumping right into it. The thing about logarithms is it's new. You haven't seen them before, so you're really going to want to stay focused, really make sure you're asking questions. With these, it takes a little bit of time. Once they click, it's good, but you kind of have to go through that struggle a little bit. So let's go ahead and get started. What is a logarithm? So a logarithm is another way to write an exponent, or to write the power that you have to raise the base to. Okay, so an exponential form is just b to the power equals y. So the logarithmic form of writing that would be log base b, okay, notice it's the same b, the same base, of y equaled that x, or that exponent that we had. So now a number way of seeing it is 5 squared equals 25. We know that's true. So writing that as a logarithm, notice how I'm going to write that with the same base, so log base 5 of 25 equaled the exponent. So it equaled the same exponent that it had. Okay. Now, so kind of the hint there is logarithms, or logs, as we write it for short, equals the exponent. That's kind of the main idea here. Okay, let's go ahead and go on to the next idea. Okay, some special logs are some things that you gotta know when we're doing logarithms. Sometimes you'll see it with just a log or just an ln. If it has just a log, that's called the common log. They'll write it like log of x, but really what it's technically there is a little 10 there. So anytime that you see this, you need to write the 10 there. You want to write it like this, because that's going to help you out when we rewrite and when you start evaluating. So if it's just log, technically it's base 10. Okay. Same with this one. If you see it with an ln, that's called the natural log. Okay. We know e is just a number, so that's e is the base when we see ln. So when we see it looking like this, we need to rewrite it with a little e there to remind us, oh hey, it's base e. Okay. These are two things that we just got to make sure we know when it comes to evaluating and rewriting logarithms. Okay, the first thing that we're going to do is we're going to rewrite these logarithms into an exponential. So think we're starting with a logarithm and we want to write it as an exponent. Okay, so when we write these, there's two problems here. Here's our first example and here's our second example. Okay, so we're going to write it as an exponent. So the first thing I need is my base. Well, my base is that little number right there. So 4 is my base. Okay. Logarithms equal exponents. So I know that 2 is going to be my exponent. So I'm going to say 4 to the 2 power equals 16. Okay. Another kind of easy way, or kind of way to remember it, is we can kind of follow this path. Okay. It starts at 4. Okay. They equal the exponent, so I picked up that 2, and then it ended up ending at 16. So it kind of follows the order of how I wrote it. Now let's try the next one. Okay. Our base is 12, so I'm going to put 12 down. Okay. It equals the exponent. Well, it equals this whole thing, so I'm going to put x minus 3 as my exponent, and it's going to end up at 6, so it's going to equal 6. Okay. That's all we're doing right there, is we're just rewriting, so these are my final answers. Okay. Let's look at the next examples. Okay, the next ones, we're going to do it in the opposite order. We're starting as an exponential, and we're going to rewrite it with a log. So that gives us a kind of an idea of how we're going to write this. Okay, first thing I'm going to write is log. We're writing it as a logarithm, so I'm going to write log down. Okay, our base number, or our big number, is 5, so I'm going to put a 5 right there, kind of a little 5 underneath that log. So log of 5, okay, of 125, and we know that logarithms equal the exponent, so it equals 3. Okay. Now I kind of like to do kind of a swirl pattern, is what I like to see it. Is it kind of follows that pattern. Say we had log base 5 equaled 125, or of 125, equaled the exponent, which was 3. Okay. So let's do that same pattern for this next one. We have log base 3, okay, of x plus 3, and that's going to equal our exponent, since it equals logs equal exponents, so it's going to equal 4. Okay. There we go. Those are my final answers. Let's look at the next example. Okay, here's our next examples. We have 3 of them here. Okay. And instead of rewriting, we're actually going to evaluate. So when it says evaluate or simplify a logarithm, it wants you to get an answer. Okay. So I'm going to go for this first one. I'm going to actually set it equal to question mark because that's what I'm trying to figure out. So what I'm going to do is I'm going to rewrite this. I want to know what 2 to the what power is going to give me 8. So think, what are you going to raise 2 to get 8? Well, it's going to be 3. All right, next one, same thing. And sometimes it's helpful, instead of doing a question mark, you can do an X if you want. So let's rewrite this. Okay, we have 4 to the what is going to give me 64. Okay, now when you're doing these, you can actually use that chart, that exponent chart that we had is kind of helpful out for these. So 4 to what power gives me 64? Well, 4 squared is 16, but 4 cubed is going to be 64. So this is actually going to be 3. Now if we look at this next one, it's a little bit trickier. If we look at it, it's 4 to the what is going to give you 1 over 64. Okay. Well, I know 4 to the 3 power gives me 64, but notice how it's flipped now. It's 1 over 64. So if we remember, how do we get things flipped or reciprocals? X would have to be a negative 3 power. Okay, let's look at a couple more examples of evaluating. Okay, for these ones, if I look at these 3, okay, this first one, okay, log of 1. We talked about this earlier in the notes. If it just has a log there, the base isn't there. So when it just has a no base, technically this is base 10, and we need to write that in there to remind ourselves what the base is, because they will never give that to us if it doesn't have it there. Okay, so now let's go ahead and do the same thing. So 10 to the what is going to give you 1. Now this one's a little bit tricky. You just got to think a little bit. 10 to what power is going to give me 1? Well, that's just going to be to the 0 power. Remember, 10 to the 0 power, or anything to the 0 power, equals 1. So my answer is just going to be 0. Okay. Now this next one, same thing. This has the ln. If you will think back, if it has an ln, we need to rewrite this with a little e. So this is actually log base e of that e is still there. So I had to rewrite that with that e there. Okay. So set it equal to x. So e to the what is going to give you e. Okay, now think, there's technically a 1 there. So let's just think, don't overthink this. E to the what power is going to equal e to the 1. Well, it's just going to equal 1. X has to be 1 since they have to match. Okay, and now let's look at this last one. 6 to the what is going to give you negative 36. Well, if we think 6 squared gives us 36, but not negative 36, 6 to the negative 2 power would actually be 1 over 36. So these two won't work. We can't use 2 or negative 2. The thing is, logarithms of negative numbers are undefined because it's not possible. So our answer for this one is just going to be undefined. Okay, because I can't raise 6 to a power to get a negative. All right, go ahead and start with your next examples or your next problems on the class kick. Give these your best shot. Ask questions. Look back at your notes. If you need to, go back and re-watch this video. Okay? Best of luck.